Hello everyone. In this video, we will talk about how machine learning works. Machine learning is a part of data science. Data science can be considered as a wide picture, or we can say which includes all the process of statistics, exploratory data analysis, feature engineering, as well as the precondition of having a proper domain knowledge. So machine learning is a part of data scientist. It's only constitutes a small portion of the data science process. Machine learning, when we talk about, is a collection of algorithms which helps us in finding out the patterns in the data. Machine learning learns the patterns inside the data, and this learning process is also called as training. So behind every learning process, a machine learning model has a mathematical equation. So that mathematical equation can be a linear equation, it can be in the kind of a complex mathematical structure, or it can use any mathematical function. So based upon that, the learning process works. Okay, but one thing which is very much important here is that the in machine learning the input data should be very reliable. If you give a wrong input data, then it can give us a bad output. So it's important to work on the data quality issues. So we can say that if we give a garbage data, and so the output will be also garbage, so the prediction will be also not much reliable. So now let's look at the following diagram. So this is our data set. So I have taken a small data set. Let's say it's a kind of a tabular data set. So we have a data called as BP, which is blood pressure, BMI, age, and the diabetes. So this is a small data set which we have. Okay. So when we talk about machine learning and consider the data, okay. So what happens here is each and every data or each and every feature. Now, when I say feature, I'm talking about the columns. So every column is considered as a dimension in machine learning. So you can say that blood pressure is on one axis, age is on one another axis, and BMI is on another axis. So if there are 10 features which make then we can consider that particular data is can be represented in 10 dimension. Machine learning will interpret as a 10 dimensional data or 7 dimensional data if they have 7 features. So just remember that each and every column is being considered as a feature here. Okay, it can be considered as a dimension in mathematical space. So now when I say column, so it also means variable in mathematical term or feature. Okay, so as I told, like each column is considered as a dimension, and each record or each data point, you see here one data point, two data point, there are so many data points which is represented in a dot. So each data point represents here a kind of a record or a kind of a row of the data. So let's say if we talk about one data point, okay, so one data point or this row will be represented in mathematical space, it will be having the following coordinates: 65, 21, and 35. Okay, so this is how the machine learning so this is how the machine learning sees the data. So it considers each column as a dimension and each data point as the value. Okay, so let's say BP is the y-axis, or let's say BP is the x-axis, y-axis, and z-axis. So it will be 65, 21, and 35 will be the coordinates of this particular row or this particular data point. So please remember, guys, this is very much important to visualize the data. Okay, but since we in our data set there are so many columns, we have more than 20 columns, 30 columns in our data sets, in our normal data set. So it's not possible to visualize it for all the data because we can only think about the three-dimensional data in our space. Okay, but you have to just keep in mind that each feature it represents a dimension in the data. So if there are n number of features, so then there are n dimension of data, and each data point is basically the representing the each record or each point in the mathematical space, and each point is basically the each row of the data set. Okay, so here let's say if we want to do the prediction of the diabetes based upon the data, that whether the person has diabetes or not. So here 0 represents that person has no diabetes, 1 represents person has a diabetes. So what machine learning does here is it takes the input. So here the input are this BP, BMI, age, and the output column will be diabetic. So the input columns are always represented in the form of X, X1, X2, X3, and X4. Like that, it is being represented, and output is being represented as Y. So yes, that's what I was saying. That input is represented by X1, X2, and X3, and output is always represented by Y. So let's say we are using any machine learning algorithm. I'm just giving a hypothetical scenario here. So every machine learning algorithm which we use has a mathematical function or mathematical equation. So if somebody asks you that how machine learning works, so you can say that there is always a mathematical equation which is working behind it. So what it will do, we have to calculate Y here. So Y is the diabetic. So it will do, let's say it uses this particular function. It's the function is x1 plus 2 x2 plus 3 x3 plus c. C here is basically refers to a kind of an error term, or there can be some quality issues or some kind of no data is being perfect. So for all those kind of disambiguities, we always add a constant term to a particular equation. Okay, so here x1 represents the BMI, x2 represents the age, x3 represents the BP. So what it will do, it will take during the training phase, what it will do, it will take the values of BMI, okay, age, BP, and it will do the prediction of the diabetes. Okay, so we get the diabetes prediction, okay, of the data, and we have the original data. Okay, so it compares the original value and the predicted value, and it says that how good our machine learning is doing the prediction. Okay, we optimize this. Okay, and we try to bring the prediction close to the actual values. So this is being done during the training phase. So once our training phase is being over, okay, we are done with the training part. Okay, we are happy with our prediction. We say that okay, our prediction is much close to our actual results. So then we can say that okay, we can use this algorithm for the prediction purpose. So then what will happen, we will just feed the input and it will do the predictions. Okay, so let's say these are the inputs here, and it has to predict that whether the person has diabetes or not. So it will predict it like this way. So it will create a kind of an equation in mathematical space, and it will try to find out whether the person has diabetes or not. So green here represents the yes, which means the person has diabetes, and red person has no. So please remember that whenever machine learning works, this is how the machine learning interprets data. It considers each and every feature as a dimension in the mathematical space. There is always a mathematical equations working behind it. Okay, based upon the machine learning algorithm chosen. So it learns the pattern from the during the training phase. Okay, using the mathematical equation, it predicts. Okay, we compare the results of the prediction and the actual results using different metrics. Okay, and then after that, what we do, we are when we are satisfied with that process, then we move it to the for the purpose of the prediction. So this is how the machine learning interprets data. This is how it works.